All right, hi Year 11s. This is Mr. Lim again, and today we're going to be talking about precipitation reactions. All right, so we've gone through precipitation reactions in class already. There's a couple of ways that can do it. We can do it the long way, we can do it the short way, and don't forget we're going to have to talk about observations as well. All right, so again, I'm going to show you how to do the long way through a couple of questions, the short way through a couple more, and then we'll talk through some observations as well. All right, remember there is the worksheet associated with this one. I don't have it out here at the moment, but here is the worksheet that we're going to work through. All right, so we're going to do a couple from question 1, a couple from question 2, a couple from question 3. All right, so let's go through. So the long way to work out precipitation reactions, let's go through that. We're going to have to work out the reactants formula, the products formula, balance the equation, determine which products will precipitate, convert all of the soluble reactants into ions, because that's what they will be when they're in solution, and then remove the ions that do not change state. So let's have a look at this one here. Lead 2 nitrate and sodium phosphate. Okay, so let's work out step number 1. Work out all of the reactants. Okay, so the reactants is lead 2 nitrate, Pb is lead, nitrate is NO3, and it's 1 minus. Since the lead is 2 plus, it is NO3, 2. Right, and then the sodium phosphate, sodium is 1 plus, phosphate is PO4, 3 minus, so sodium phosphate is Na3, PO4. Okay, that's the reactants. Number 2, the products. Now remember, when we're doing the products, we have to swap the metal of one with the negative ion of the other, and the positive ion of that one with the negative ion of that one. So we have 2 products. We have lead phosphate, lead 2 phosphate, so that's Pb. Since it's a 2 plus and this is a 3 minus, this will be 3, this will be bracket PO4 bracket 2, and sodium nitrate, so sodium nitrate. Okay, now step number 3, we can write out a full balanced equation. So PbNO3 2 plus Na3PO4 goes to Pb3PO4 2 plus NaNO3. Balance this equation, 3 here to get 3 NAs, 3 here, we might have to go 2 here, we might need a 6 here, and I believe we're all balanced out. All right, so now we have to work out which products will be precipitate. So we got to check out lead phosphate and sodium nitrate. Okay, so to do this we need our data sheet, and our data sheet in the middle we have our solubility table. Okay, so solubility table, we're having a look here. We have lead phosphate, so we find the phosphates. Phosphates are here, they're in the insoluble table. So that most phosphates are insoluble except for sodium, potassium, and ammonium phosphate. Is lead phosphate one of those? No, it's not. So lead phosphate is insoluble. Pb3PO4 bracket 2 solid. Right, NaNO3 nitrate, sodium nitrate. All nitrates are soluble, there are no exceptions. Okay, so this NaNO3 is aqueous. AQ, solid, AQ, AQ. All right, so now that we know that this one is solid, all the rest of them can be turned into ions. So we go Pb2 plus AQ and NO3 minus AQ plus Na plus AQ plus, and we'll have to write it over here, PO4 3 minus AQ goes to, right, Pb3PO4 lead phosphate and sodium ions AQ and nitrate ions AQ. Okay, so we've written out every single soluble substance as ions, and so we can look at the things that haven't changed states. The sodium hasn't changed states, the nitrate hasn't changed states. Okay, so we can remove those. Let's go remove those. Out goes that one, out goes that one, out goes that one, out goes that one, and what are we left with? We are left with Pb, 3PO42 solid, comes from Pb2 plus aqueous plus PO43 minus aqueous. We'll have to balance that out. A 3 here, a 2 here, and that's it. All right. So this is how you would write out this ionic equation for lead nitrate and sodium phosphate. Okay, and as you can see, we went through quite a lot of steps, quite a lot of writing. That's not probably the most efficient way to do it. Okay, that was the long way, right? Showing all of the concepts and the ideas that we're talking about for an ionic equation. But let's go do the short way. Okay, so we're now doing F on the question sheet, all right? F over here, potassium hydroxide and silver, 1 silver nitrate. Okay, and we're going to do it the short way. What's the short way? Work out the products which will precipitate, work out the ions that will make the precipitate, and then balance the equation. Okay, so let's go through. So, potassium hydroxide and silver nitrate. So, we know that we need to work out which of the products which will precipitate. So, we have potassium nitrate and silver hydroxide. Okay, so let's have a check. Potassium nitrate, will that precipitate? All nitrates are soluble with no exceptions. Then let's have a look. Silver hydroxide. So, all hydroxides here, hydroxides, except for silver hydroxide, okay, which will react with OH minus to form Ag2O. Right, so this is going to be a bit difficult. So, we know that this forms Ag, effectively, Ag bracket or OH solid. Okay, we're going to treat this as if it stays like this and then we'll deal with what happens to it later. But anyway, so this is the precipitate. What are the two ions that made it? Okay, the two ions that made it are the hydroxide ion and the silver ion. Okay, then we put these together. We have OH minus aqueous plus Ag plus aqueous goes to AgOH solid. Right? It will turn into the AgO2, but we're not going to worry about that one for now. Okay? So don't worry about that. That is what we should really think about. Okay? This one will turn into Ag2O solid, but we won't have to worry about that one either. Okay? Let's go on with the next one. Okay? Sodium sulfate and copper 2 chloride. So, number one, we have to work out the two products. It's going to be sodium chloride and copper sulfate. So, sodium chloride, most chlorides are soluble. Sodium chloride is no exception. And then the other one was copper sulfate. Most sulfates are soluble. Right, the insolubles here, are there copper in there? No. So what do we write? No precipitate formed. Well, that was easy. Right, let's go look at one more. Potassium iodide and cobalt 2 chloride. Okay, so potassium iodide, or we can instead match potassium and chloride together, and cobalt iodide. So potassium chloride, most chlorides are soluble, potassium is not one of the exceptions, and cobalt iodide, most iodides are soluble, except for these two, which cobalt is not. So therefore, again, no precipitate formed. Well, that was a bit boring. Let's go pick one that actually will form a precipitate. Okay, so let's see here. Let's do something like potassium iodide and cobalt chloride will do L, because what's the point of making a video if you're not going to have something react? Potassium iodide and copper chloride. Oh no, that's not going to work. No, that's not going to form something soluble either. Let's pick something that does form something insoluble. Let's do the copper hydroxide, which is insoluble. Alright, so let's do the J instead. We're going to do potassium hydroxide potassium hydroxide and potassium hydroxide and copper 2 chloride. Okay, so let's try that. Potassium hydroxide, copper 2 chloride. So the two combinations are potassium chloride and copper 2 hydroxide. So potassium chloride, most chlorides are soluble except for those, which potassium is not one of those. And copper hydroxide, most hydroxides are insoluble except for these, of which copper is not one of those. So we know that copper hydroxide will be insoluble. We know that the two things that will make up this will be copper 2 plus aqueous and the OH minus aqueous, and therefore we can work out that it's just copper 2 plus aqueous plus OH minus aqueous goes to copper hydroxide to solid. Right, so you can just write out this line here without having to go through the other steps, all right, because you know that that's going to be the solid, that's going to be just down there, and you're just going to make sure you balance it to there, and now it's balanced. All right, so let's move on now to one of the observations. Right, observations. So when we deal with observations, we have to think if they are stoichiometric ratios. For this example, they are in stoichiometric ratios, and we must consider, we have to write out all the reactants, write out all the products, and the solids. We have to give them colors if they are colored, and ions, the solutions must be colored if they are colored. So let's have a look at this particular question here. Barium chloride and sodium sulfate. Okay, so first of all, you should work out, just like we did before, the actual ionic equation. Sodium chloride is soluble, and barium sulfate, most sulfates are soluble except for barium sulfate here. So barium sulfate is insoluble. It's going to be formed from barium 2 plus ions. How do I know barium's 2 plus? Because it's on group 2 of the periodic table. And sulfate ions. How do I know that sulfate ions are 2 minus? Because I just do. Right. Now we have to write out the observations. So, barium chloride. This is a soluble solution. Right, we have to work out what color that is. So we have to look at our data sheet again, and it's on the next page. So barium, we have to look at the colors of ions in aqueous solution, and barium is not there. So if it's not there, what is it going to be? It's going to be colorless. So this barium chloride, the observations, is a colorless solution. Plus sodium sulfate, again, is sodium on this list of colored ions? No. So this is another colorless solution. Forms. So what color is this barium sulfate? So first we look up here, because it's solid. Barium sulfate isn't there. Okay. Then we look at the colored ions in aqueous solution. Barium is not there. So if it's not there, and then it's not here, it's going to be a white solid. And then we have to think, sodium chloride, what color is sodium chloride? Sodium's not there, chloride's not here, that's going to be a colorless solution. So even though we don't write the sodium chloride, we need to recognize that it's still a colorless solution. So this is the observation for this particular reaction. Take into account, work out the ionic equation, work out the color of those two reactants, write them down, and it forms a white solid, the precipitate, and whatever the color is of the other solution. Right, let's have a look at the next one. Sodium sulfide and copper 2 nitrate. So let's work out the precipitate and the ionic equation. We have sodium nitrate, which is sodium nitrate is over here. All nitrates soluble, no exceptions. And copper sulfide. So most sulfides are insoluble in water, and copper is not there. So therefore, copper sulfide, copper 2 sulfide, right, is insoluble. How is it made? From copper 2 plus ions, Aq, and sodium sulfide, sulfide ions, Aq. All right, now we can do the observations. So we need to know what color sodium sulfide is. So what do? We look through here. We know that it's a solution, so we know that it's down here. We look for sodium or sulfide, and neither of them are there. So therefore, this is a colorless solution. That's this one here, sodium sulfide, colorless solution. Copper 2 nitrate. So, copper, is it here? Copper, yes it is. Copper 2 plus, and it is blue. So this is, the copper 2 nitrate is a blue solution. And this forms, what color is the copper sulfide? So we look up the top here, copper 2 sulfide is black. So we have a black solid. And what color is the sodium nitrate? We've already established the sodium is not there, so therefore the sodium nitrate is a colorless solution. Okay? So that's how you would do it. Both reactants, both products. Even though you don't see them, you need to know that they are there. Let's have a look at the next one. Now we're going into the point where we are looking at things in excess. Okay, so I have excess copper 2 sulfate and barium nitrate. So let's work out the precipitation reaction. Okay, I have copper nitrate, all nitrates are soluble, okay, and barium sulfate. Barium sulfate is, most sulfates are soluble in water except for barium sulfate, which is an exception. So the barium sulfate is going to be insoluble. All right? And it's going to come from barium 2 plus ions and sulfate ions. And there's your balanced ionic equation. Right? Now let's look at some of the observations. So, what color is the excess copper 2 sulfate? So the copper 2 sulfate, let's have a look. Copper ions are blue in color. So we have a blue solution added to. What color is barium nitrate? What color is the barium ion? Not there, so it's a clear colorless solution. To form, now, what color is the barium sulfate? The barium sulfate, is it up here? No. What color is it down here? Not there. So therefore, barium sulfate is a white solid. And what color is the copper nitrate, which is also produced here? Okay, the copper, again, is still blue. Blue solution. Now, if you wanted to be really accurate about this, the blue solution here, when you add the colorless solution, is going to dilute the concentration of the copper ions. And since the copper ions are the things that's making it blue, it's actually going to be a slightly less pale, slightly less blue. So you would say the final solution is less blue, or you can say paler, than original solution. Okay? Let's go work out the next one. Excess nickel 2 nitrate and sodium sulfate. So let's work out the precipitate. We've got nickel sulfate or sodium nitrate. Okay? So nickel sulfate, most sulfates are soluble in water, and nickel is not an exception. Sodium nitrate, again, soluble in water. All nitrates are soluble, so no precipitate formed. But that doesn't mean your observations are nothing. What color is the nickel 2 nitrate? What color is nickel? Nickel is down here. Nickel 2 plus is green. So a green solution added to a, what color is sodium sulfate? A colorless solution. No solid formed. Final green solution, less green than initial green solution. What have I done wrong there? Right, I really should have said something along the lines of no solid formed and a green solution is formed. Right? But it kind of says in it anyway. All right, so that's how you do precipitation reactions. I want you to really practice these because they'll be in the assessment. All right, so just remember, when you're going through observations, you need to go check the ion, for solids, you need to check the ionic solids box, then followed by the colors of the ions, and then if it's neither there or there, it'll be white. For ions, which means it's the soluble substances, you only need to check the colors of ions, right? And it'll be colorless. Some of the substances here are actually soluble in water. So sometimes you'll say, okay, copper to carbonate, actually no, that's not that one. Copper to chloride is soluble in water. So this will be green as a solid, but when it dissolves in water, it'll be blue as an ion. Okay, so you got to make sure that you would recognize you only use this table if it is a solid. Okay? But then you can use this table only if it is in ionic or if it's not in that table above. All right? And so, check those, make sure that you're working out your precipitation reactions, and then make sure that you are trying all of the questions within this worksheet here. All right? Make sure you get that one done, and then we'll see how you go in the next assessment.